Hello, good morning everyone. So today we are going to discuss about one more kind of dependencies, joint dependencies, and then based on joint dependencies we'll be introducing fifth normal form. And after that we'll look at one more concept, and that is the temporal dependencies. So today we are going to quickly look at all those concepts, and we are going to conclude this unit number 3. So let's begin with joint dependencies. Let us see the definition of joint dependencies. A joint dependency denoted as JD in parenthesis R1, R2 up to Rn, specified on a relation schema R, specifies a constraint on the relation R. So we are having the schema R, right? And we are considering the decomposed relations R1, R2 up to Rn, right? So a joint dependency denoted by JD R1, R2 up to Rn specified on relation schema R specifies a constraint on the relation schema R. This constraint states that every legal relation R on R should have a lossless joint decomposition into n relations R1, R2 up to Rn. That is, for every relation R on capital R, this condition should be satisfied. And what is that condition? See here, we are saying that the relation is being decomposed into n relations. Meaning, so obviously this R1 is having some schema, this R2 is also having some schema, meaning R1 is described with some attributes, R2 is described with some attributes. Similarly, Rn is also described with some attributes, those belong to capital R, right? So R1 is subset of R, R2 is also subset of R, and so on, right? So if we pick few of the attributes, we are using here projection operation. So if we pick few attributes, say R1 from R, similarly some attributes R2 from R, and so on, and if we try to have a join of all those different relations, then whatever we are getting is the original relation R, right? So this projection of R with respect to attributes R1 is nothing but the decomposed relation R1. This is my R2 and this is my Rn. So if R gets decomposed into several relations, and if we try to find out the join of these relations, then definitely we'll be getting the original relation R on capital R. So we are saying that the joint dependency puts the constraint that every legal relation R on R should have a lossless joint decomposition into n number of relations R1, R2 up to Rn. Right? Now, please note here that the multi-valued dependency that we have seen earlier is a special case of joint dependency where n equal to 2. What is n? Number of relations in decomposition. So multi-valued dependency is a special case of joint dependency where n is equal to 2. Right? So in other words, we may write a joint dependency denoted as JD R1 R2 implies the multi-valued dependency of the form R1 intersection R2 multi-determines R1 minus R2. I repeat, R1 intersection R2 multi-determines R1 minus R2. So this is the definition for join dependencies, right? Now, based on these join dependencies, we are having a fifth normal form, which is also known as PJNF. It is 5NF, or it is also known as PJNF, Project Join Normal Form. So let us go through the definition of fifth normal form. A relation schema R is in 5NF with respect to the set F of functional, multi-valued and joint dependencies. If for every non-trivial joint dependency JD of the form JD R1 R2 up to Rn, every Ri is a super key of R. So in fifth normal form, what we are saying is we are having the relation R, and in decomposition we are having say R1 R2 up to Rn, right? So a relation schema R, we say that this is in 5NF with respect to given set of functional dependencies, multi-valued dependencies or joint dependencies. If for every non-trivial joint dependency, every Ri, means this R1, R2 up to Rn, forms the super key of this original relation R. So in my decomposition, I am having this R1, which is one relation. I am having this R2, which is another relation. So if I consider the original relation, then this R1 forms the super key of R. Similarly, R2 also forms the super key of R. Rn also forms the super key of R. So if it is possible to decompose the original relation R in set of relations R1, R2 up to Rn, and if every such relation forms the super key of R, then we say that this relation schema R is in 5NF. Right? So this is really very stringent form, normal form, very stringent normal form. And it is very difficult to practically discover the joint dependencies in case we are having hundreds and thousands of attributes in our relation. So finding out joint dependencies practically in the databases with huge number of attributes is really impossible. Right? So the normal form, which is based on joint dependencies, that is 5NF, is mainly used from theoretical point of view. Right? And there are very few practical implications of 5NF. So 5NF is not meant for practically designing a database. It is simply discussed or introduced in theoretical point of view, and that is why we are not at all going into the details of this 5NF. Only thing is, I want you to know what is joint dependency and what is the definition of 5NF. Right? So I hope you must have understood the joint dependencies and the definition of fifth normal form. Right? Now, the last point that I want to discuss is the temporal functional dependencies. Meaning of this word temporal is with respect to time. So, if we are considering any facts, any details with respect to time, then we say that these are temporal facts. Right? So, similarly, we are having temporal functional dependency. So what we mean by temporal functional dependency, or let us first see what is temporal data. Temporal data are data that have an associated time interval during which they are valid. What does this mean? See, whenever we are building a database, right, we go on inserting data into our database management system or database application. So not necessarily all the data is valid at any given point of time. I repeat, we are having lots of data in our database system. So it is not necessary always that all the data is valid at all times. But some data is valid for a particular time interval. Right? So the data which is dependent on certain time intervals is known as temporal data. For example, suppose we are having our university schema. Right? So in our university schema, we are having one relation, say instructor. In this instructor relation, we are storing the data related to instructors. Right? So we are having the instructor ID, name of the instructor, department name of the instructor, right? And salary of the instructor. Suppose we are having few more attributes, say address of the instructor is also stored. Now, it may happen that the instructor was residing at some location, at some place during some period, but afterwards the instructor has moved to some other location. It is possible, right? And if we are trying to maintain the temporal records like this, say for example, during one time interval, the person was staying at one particular location. During another time interval, the person is staying at different location. So with respect to time, my data, address of the instructor is changed, right? So if I am having such kind of a data in my database, and if I want to maintain all this data with respect to the associated time intervals, then such kind of a data is known as temporal data. And if I want to store such kind of a data, I need to design my database accordingly. Meaning, while designing my database, I need to add few more attributes like start date, end date, something like that, so that I can mention in which period this data is valid. Right? Now, the functional dependencies that hold at particular point in time are called the temporal functional dependencies. So we know now what is temporal data. So associated with temporal data, we are having some functional dependencies. These functional dependencies hold at a particular point in time. Right? Sometimes it may happen during some other time interval, some policies of the enterprise are changed. And due to change in policies, it may happen that the constraints in terms of functional dependencies, those we would like to impose upon, are also changed. Right? So the functional dependencies, meaning the constraints. Functional dependencies are nothing but the constraints. So functional dependencies or constraints that hold at a particular point in time are called as temporal functional dependencies. Right? Normally, a temporal functional dependency X determining Y with this notation for denoting that this is a temporal dependency. Right? So formally, a temporal functional dependency X to Y holds on a relation schema R on R if for all legal instances of relation R on R, all snapshots of R satisfy the functional dependency X determining Y. What it means? See, we have seen this word snapshot earlier. So what is a snapshot? Snapshot is the status of our database at a particular moment. Right? So snapshot of a database meaning it is the status of my database at a particular instance of time. Right? So what we mean by temporal functional dependency? Temporal functional dependency holds on a relation schema if for all legal instances of R, all such snapshots of R during that time span satisfy the functional dependency X determining Y. That's all. Right? So, in a sense, you should remember what is temporal data, what is temporal functional dependencies, and how it has formally been defined. Based on temporal functional dependencies, we need to have some modifications in our database design. So in our ER model, in our relational model, we need to reflect those temporal changes in terms of some attributes. Right? So we are not going into the details of all those things. But you should know that there is a concept of temporal functional dependencies. And that is meant for temporal data, meaning the data that is valid with respect to some time interval. And the functional dependencies, those are valid for that particular time interval such that all legal instances or all snapshots of the relation taken during that interval of time will satisfy the functional dependency. Right? So I hope you must have understood the concept. So I hope that you must have understood this concept now, and this is the end of unit number 3. So as I stated earlier, for this unit number 3 we used 2 textbooks, right? One is Database Systems, a practical approach to design, implementation and management by Connolly, and other is the Database System Concepts by Korth, Sudarshan Korth. So these 2 are the textbooks, those we used for this unit number 3.